Whoop. That's a spider web. Oh my goodness. Right there. Okay, one more time. Hey team, I'm Maddie. Welcome to Science Sci It Up, and today we are talking about partial pressure. In previous videos, we have learned about the chemical composition of the atmosphere, and we've learned about atmospheric pressure, and now we are combining those two concepts together to talk about partial pressures. The idea here is that if you have a gas that's made up of a bunch of other gases, then you could break down the total pressure being exerted by that gas into what's being exerted by each individual part. If this box is just sort of, we captured normal atmosphere in a box, then we would expect our nitrogen to be 78% of what's in there, oxygen 21%, and then we know that last 1% remaining, 1%? Yeah, 1% remaining would be everything else. So just to make our lives simple, let's just think of that everything else is just the water vapor. It'd be really, really easy to think that, oh, okay, great. If nitrogen is 78% of what's inside here, 78% of the atoms in this box are nitrogen, diatomic nitrogen, then shouldn't 78% of the pressure be coming from the nitrogen? But we've got to be a little wary, because that's a little too simple, because what we forgot to take into account there was that nitrogen and oxygen and water vapor all have different masses. So in diatomic oxygen, there's going to be, it's two oxygen atoms bound together, and so each of those is going to have like 32 neutrons and protons. It also has electrons, but electrons weigh very little compared to neutrons and protons. So for right this second, let's just think about the weight as related to the number of things in the nucleus. Diatomic nitrogen, well, nitrogen has 7 neutrons, 7 protons. So diatomic nitrogen would only have 28. So even though I have more nitrogen than I have oxygen, each oxygen atom weighs more than each nitrogen atom. So if I broke down the partial pressures, it's not going to be 78% of the pressure comes from nitrogen and 21% comes from oxygen. A little more of the weight of this air is coming from the oxygen than like the percentages. Hope that makes sense. But anyway, the basic idea here is that if we know the partial pressure of each of our different atoms, right, each of our different molecules, then if we add all those pressures up, we should get the total pressure. So in a quick formula, that looks like this. The total pressure is going to equal the pressure from the nitrogen plus the pressure from the oxygen plus the pressure from the water vapor. I bet right now you're thinking to yourself, well, that's all well and good, Maddie, but why in the world would we ever need to know the difference in pressure from nitrogen and oxygen? And that is a totally fair question, because in reality, nitrogen and oxygen partial pressures aren't gonna really change our chemistry or what's going on in the atmosphere very much. But what is really important is that water vapor. So usually when we're thinking about partial pressures in the atmosphere, we're not going to think about each individual component. We're going to think about the pressure from the dry air and the pressure from the water vapor. The total pressure is the partial pressure from dry air plus the partial pressure of water vapor. I still haven't quite gotten to why this is a thing we would want to do. And for now, let's just think about how tricky and ill-behaved water vapor really is. Because water in the atmosphere can be in its gaseous phase, in a liquid phase, or in a solid phase, right? We can have clouds, so liquid water suspended up in the air. Those clouds could also be made of ice particles instead of just liquid water. We could be making precipitation, right? We could be condensing dew on the surface. So water vapor has this nasty habit of changing phase, left, right, and center, doing crazy stuff to like our atmospheric chemistry or what's going on in our atmosphere. The phase of water is actually also really important for some temperature effects that we're gonna get to in a few videos down the line. Since the phase of water is a function of both temperature and pressure, understanding how the pressure of water vapor is going to change can be something that's pretty important. Okay team, that's all I've got for you today. I hope you liked this video and I will see you all in the next one. Bye!